Imagine the Earth as a living, breathing entity constantly at work beneath our feet. Sometimes, this internal activity culminates in one of nature's most dramatic displays, a volcanic eruption. It is a powerful reminder of the incredible forces shaping our planet. The pathway for magma to erupt involves a fascinating journey from deep within the Earth, typically through a distinct channel called a conduit, eventually reaching the surface through an opening known as a vent. This process begins from below where we stand. Magma forms in the Earth's mantle or lower crust where intense heat and specific conditions cause rock to melt. This molten rock is inherently less dense than the surrounding solid rock. Because of this buoyancy, magma naturally begins to rise. It often collects in large underground reservoirs called magma chambers, which act as temporary storage areas. As more magma accumulates in a chamber and dissolved gases within the magma exsolve, pressure builds significantly. This immense pressure, combined with the magma's buoyancy, forces the molten rock upwards. It exploits existing weaknesses or creates new fractures in the overlying crust, forming a network of cracks and pathways, including dikes and sills. The primary vertical channel that funnels magma from the chamber to the surface is known as the volcanic conduit. This conduit acts like a pipe, allowing the magma to ascend rapidly. The summit of this conduit at the Earth's surface is the vent, which is the opening from which lava, ash, and gases are expelled during an eruption. The physical characteristics of the magma, such as its viscosity or thickness and gas content, heavily influence the eruption's style and intensity. Understanding this geological pathway is crucial for monitoring and predicting volcanic activity. Scientists use various methods to detect magma movement, including seismographs to record ground tremors, and global positioning system instruments to measure ground deformation as magma chambers inflate. Changes in gas emissions from fumaroles and vents can also indicate that magma is rising closer to the surface, signaling a potential eruption. This intricate journey from deep melting to explosive releases reveals the Earth's dynamic nature. The concept of a magma chamber, the conduit system, and the vent are not just theoretical constructs but representing real, observable geological features. The interplay of pressure, buoyancy, rock mechanics, and magmatic properties dictates the very specific route and style of each eruption. So, from its genesis as molten rock hundreds of kilometers beneath the surface to its explosive or effusive emergence, magma follows a well-defined geological route. This continuous process of magma generation, ascent, and eruption is a fundamental mechanism of planetary cooling and crustal growth, continually sculpting the Earth's surface and providing vital insights into our dynamic world.